Hi, I Aziz welcome you to CoedMaster, and in this video I am going to talk about order of growth of space or space complexity. So let's get started. When we talk about order of growth of a function, we generally talk about the time taken by a function to solve a problem in terms of input size. And we generally consider our input tends to infinity. In space complexity, we generally care about space, not the time. So what is meant by space complexity? Space complexity simply means the order of growth of space, memory or RAM in terms of input size. So it means when our input tends to infinity, how much space our program is going to take. And we want our programs to take minimum space. And we want our program to use the space efficiently also. Why? Let's say you have developed an application and it is consuming all the memory. It means you do not have memory left for the other applications. How other application is going to run without the memory? And nowadays we run multiple applications at the same time. We generally do multitasking and multi-programming. We want our computer to run as much as programs as possible. And to run all the programs efficiently, we have to develop an application in such a way that it takes less memory as possible. And even if it takes memory, then it uses the memory efficiently. That's why space complexity is a crucial topic to understand. So let's understand with an example. Let's say we have a program to find a square of a number, and we wrote two programs to solve this problem. This one and this one. So on the left side, you can see this program takes n as an input and simply doing a constant operation. It's a mathematical operation and all the mathematical operations are done in constant time. So it is simply using a formula n into n to calculate the square of a number. On the other end, this function is running a for loop to calculate the square of a number. This function takes n as input, initializing a variable result, running a loop from 1 to n and again returning this result. And this is performing operation here, response plus n. So if I talk about the space complexity or the order of growth of this function in terms of space, then it would be theta of 1. Why? Because on the left side, this function is doing only constant operation. So we have to initialize memory for only n. And n is what? It's a constant. That's why the order of growth of this function is theta of n in terms of space. Now let's talk about this function. How much memory we need to run this function? So if you look at this function carefully, you find three variables. One is n, one is result, and one is I. So we need to assign memory for these three variables. So for three variables, we need a constant amount of memory. So that's why the order of growth of this function is going to be a constant. And we can see it clearly that even if you pass n equal to 1 or n equal to 1000 or n equal to 1 lakh or n equal to 1 million, it's going to use three variables only, n, response and I. That's why the order of growth of this function is theta 1. It means constant order of growth in terms of space. Okay, so far so clear. Let's move on. So this is our second example. In this example, we have a function with the name arraySum, and what it does, it sums all the value of array. So we are passing array as an input in this function with the size of array. Okay, in first statement we are initializing the sum with 0, then we are running loop from 0 to n, and we are adding all the values one by one in some variable, and at the last we are returning the sum. Now what is the order of growth of this function in terms of space? So first of all, this function is taking array as an input. So the order of growth of this function is completely depend upon the size of the array. If you pass the array having number of elements 100, then the order of growth of this function is going to be 100. If you pass an array with 1 million elements inside of an array, then the order of growth of this function is going to be 1 million. So how much space you need to allocate for this function to execute? It depends upon the size of the array. Simple. If array is large, then you need to allocate a large space. If array is small, you need to allocate small space. Okay, I forgot to tell you one thing, that so we use asymptotic notation to represent time taken by a function. So in space also we use asymptotic notation, and in time also we use asymptotic notation only. So how we represent the space taken by this function? It is clearly the theta of n, because the space order of space of this function is directly depends upon the size of array, right? So before we move on, let me introduce a new term, that is auxiliary space. So far in all the examples we use the term space complexity, but there is a lot of difference in between auxiliary space and the normal space complexity. So auxiliary space basically means how much extra space or temporary space required by a function to solve a problem. So in auxiliary space we talk about the order of growth of extra space in terms of input size. Let me explain you why we are using auxiliary space here and why we are not using normal space complexity. Let's say we saw this example before. So here if I analyze this function, we are taking array as an input with the size of an array, right? We are doing sum of all the values of array and we are just returning the sum. So if I ask you what is the space complexity of this function, so obviously the space complexity of function is going to be the size of the array. But anyhow this function is going to take array, and if the array size is n, then the space complexity is n. We are actually interested to find out that what is the order of growth of auxiliary space. Why? We differentiate function, that which function is best according to the space taken by a function. Let's say we have written two functions to sum the elements of an array. Obviously both the functions are going to take array as an input, but we specifically need those functions that takes minimum auxiliary space. If I talk about this function, the order of growth of space of this function is going to be theta of n. Why? Because this function is taking array as an input. Now if I ask about the order of growth of auxiliary space this function is taking, so by default this function is not taking any extra space. This function is simply taking constant space for initializing, for allocating memory for variable n, for sum, for I, and that's it. That's why these are two different things. The order of growth of space is theta of n, and order of growth of auxiliary space is going to be theta of 1. Let's understand this with more examples. Let's say we have array problems, or we are performing any operations on arrays. So whenever we perform any operation on array, then obviously we have to pass this array inside the function. So anyhow the space complexity of that function is going to be theta n. So if we have 5 different functions to solve a problem, then all the five function has going to be theta n complexity, right? But we want the efficient function. So in our case, what will be the efficient function which takes the minimum auxiliary space, right? So that's why we generally do not talk about space complexity. We are generally interested to know about how much extra space this function is taking. Okay, so let's say if I talk about the sorting algorithm, in insertion and the selection sort, these two algorithms are in space algorithm. It means when you pass an array to this function, they are going to sort an array in place. So these two algorithms do not require any extra space or any extra array to sort an array, right? But on the other hand, if I talk about the merge sort also takes array as an input, but merge sort is a recursive based solution, and in merge sort we generally have to create new array and we have to allocate memory for the new array to sort the existing array, right? So there are difference in both the type of algorithms. In insertion sort and selection sort, if I talk about the auxiliary space, the order of growth of space in insertion and selection sort is almost theta 1. And if I talk about the merge sort, the order of growth of auxiliary space in merge sort is going to be theta of n, because merge sort uses extra space to sort an array. I hope by the end of this video you have a clear understanding about space complexity and why it is important, and how to calculate the space complexity or the order of growth of space of a program. This is it for this video. Thanks for watching. See you in the next video.